Now, I have to warn you, I have a very dry sense of humor, and at the very start, I know there's going to be questions at the end of this, but I want you to keep one thing in mind. A 20-second question to a spec writer requires a 20-minute answer. Thank you. So, my name is Keith Robinson. I've been writing specifications now for about 30 years. I'm also a vice president of Construction Specifications Canada and sit on many North American committees on the development of specifications and specification information. Two of the committees I actually sit on and actually chair. One is tables 31 and 32 for Omni class. That's the roles and responsibilities in the discipline classifications. And the other one is master format maintenance task team. So if you wonder where those numbers and titles come from, the buck stops here. I actually co-wrote this. David Watson was going to be making this presentation initially. He's a person that works, he has his own company called Digicon. He actually sells a master specification database, and he also develops software for preparing specifications. So some of this information is a little bit at a higher technical knowledge than I have, but I understand the basic premise behind it. So I'll try and make as best a presentation of that as I can. When it comes to specs, that's mostly my information. I can probably address that a whole lot easier. So very quickly here, what are specs? What the role in specs in BIM, specs over the life cycle of the building, and that includes the facilities management side of it. And I was really interested in hearing some of the problems, particularly with standardization of terms and language. And I might have a solution for that. So that's got some good news here. And it comes down to that standards for information management. What are specs? And this is important to know. It's more than a list of BIM element properties. In fact, a spec is more than just a listing of products. It's as we've seemed to have moved forwards in the BIM world and this ability to drop in elements and families that are provided to us by manufacturers. And I'm sorry, if there are manufacturers in the room, it's not meant to reduce the quality or the need for those components. But that seems to be the whole thought process is I put down a product, therefore it is, when really in the specification and the construction documentation phase, the consultant is really interested in presenting information to the constructor so that they can determine adequate means and methods. These whole levels of development that we keep getting taught in the BIM management process, IPD, integrated project delivery, is very important on this, and understanding everybody's roles. Specs also can set up the framework for the sharing of the models. By the way, a huge proponent in sharing freely. Somebody should pay, but it should not be the contractor. Just saying. The value of the model is what you put into it, and if somebody pays for that model, there's an expectation for, I'll say, a deliverable. You buy a car, you expect it to run. Really, the architectural and engineering models are very representational. They're not to be constructed from. So far as the specs are concerned, it's more than just a list. In fact, there's no way that you could contain all the information within the BIM solely because of all the different decisions that have to be made. One decision in the model could equal 7 or 8, 15 decisions in the actual specification. So for example, we have installation administration requirements, the meetings that you set up for reviewing mock-ups, for determining pre-construction information, even at times for communicating design intent. I know that's another word that isn't very friendly for some people, but sometimes the architect has a need to describe what the vision is and have that interpreted by the person who is actually building it. Temporary construction, that is definitely not covered by BIM, and it's not even in the responsibility of the architect or the engineer to provide. That is something the constructor actually ends up probably in two forms of construction delivery: construction management, design, build, providing information into the specification so that the information is being addressed by the people who are in most control of that information. The specs, certainly in the early portions of the project, record design decisions. It forwards out those design decisions so they can be more effectively used by the contract language. Again, within the different standard forms of contracts we use in Canada, the CCDCs we're very familiar with, and again, in particular with construction management, design, build, there are two sets of documents. So the contract documents, the ones used for bidding, the addenda and any bid revisions that go along with it, and that's what establishes the contract. And then there's the second documentation set, which is called the construction documents, which is the compilation of information, a very big part of the model, and the sharing of the model. And again, the collaborative input of information as the project proceeds, to the point where, with any luck, at the facilities management stage, that any replacement of product from specified criteria or any initial commissioning information can actually be turned over as a part of the O&M manuals. And I agree with the scanning component. I end up with scans all the time, and fortunately, if you have full versions of Adobe, you can run OCRs on it, but it makes for very big files after the fact. So what are specs in that sense? They're a design description. This is very small on the screen here. But basically, they can move forward throughout the project, basically carrying forward the common information structures among the various documents as we move forward from preliminary project descriptions to outline specifications, to bidding documents, to construction documents, to the final handover to the owner of the as-built documentation. So in the early stages, we deal with PPDs, preliminary project descriptions, outline specs, and it's typically based on uniformat, very elemental, oftentimes also referred to as the design spec. The idea being it's a very high-level description. You can take your basic wall assemblies and add additional description, maybe material names, pictures of outcomes. It's a very open format for describing project requirements, and immediately usable by people who are creating budgets. It's easier to change than changing the typical master specification. They're very good at describing the performance required. By naming products doesn't necessarily mean those products have to be used, but that the performance level established by name of that product is what is conveying the true intent. These can be bound by the contract in the sense of the design builder. And anybody in the room, I know we have several contractors having experience with design build. Yeah, it's a very cool thing. I think it's a very collaborative process. Allows for design assist. It actually allows for early sharing of model information. Right now, I can tell you, I'm working on the new Edmonton Arena. If anybody's seen the pictures of the outside skin of this building, we basically ship that component of the model out, along with a written specification, give it to a metal fabricator in Kansas City. They do whatever it is they do, and we just drop it back into the model, and I then have a specification that I can actually use and know will work based on the information very early on in the project. And again, it really helps in setting up budgets. And if anybody ever questions the decision later on in the project, that there's a record of that decision making as you go through the project. I'm just thinking that this isn't actually going the way I expected it to. There's a bit of an animation that's going on here. Anyway, uniformat, as you can see, on the one side there's a listing of A, B, C's, D's, E's, F's, and sorry, up to Z. We skip a whole bunch because there's room for improvement in adding stuff in. But you can see how if you've never seen uniformat before, how the structures of the building are broken out by substructure, the shell of the building, the interiors of the building, and so on until you can describe the entire project. The preliminary project description takes those headings, doesn't reorder the numbers, and maintains the numbers so that in fact this information can be exported directly to the costing software used by constructors and hopefully establish a more accurate budget process in the beginning stages of the project. Early specs in BIM. typically connected to the elements of the model, not necessarily the actual products and materials. And again, as I think I've already pointed out, owner benefits using BIM by having the documents record those decisions early and make them accessible later in the project. I also use it when we're moving project forwards through the different phases of design development, through schematic design, DD, construction documentation, bidding, that there's also an ability to sit down with a script when you're passing the model and the specifications over to different people. You can also use these early specifications as an interview tool to make sure you've actually picked up all of the design decisions that the architect or the engineer are making within the project. Then we get into the actual contract documents, and these would be the full text type specs that you're used to seeing, the full master format, the 3 or 4 volumes, 1,200 pages, stack them up high. You can hold any door open in any stiff breeze type of documentation. These are the contract documents that are used by the constructor and provides quality and performance requirements, and again, key quality and performance requirements. Even when products or a series of products are named in the specification, they should have been researched to have fulfilled the performance requirements listed. But that also allows the constructor then to come back and offer substitutions to that. A big part of the BIM process is integrating that substitution information back into the model, the whole as-built process. This is key. I know this is still problematic as an issue for specifications. This is a huge one. Good, clean, bi-directional information flow from the specification into the model and from the model back into the specification. At this point in time, there's no way if a change was made in the specification to have that information updated in the model. There's no software suite that does that. I would say when we get to that point, then we have a true, open, readable document. The idea being that specifications are free text. They're sentences, they're paragraphs. They're written in language context using grammar, hopefully, and are probably also, in order to maintain the fact that they should be read, should also be interesting to read. No, nobody's yawning yet. That's good. Thanks. So, and David has actually introduced the word here, federated application. BIM spec application is a federated application in that the model holds the data and the specs hold all of the rest of the decision-making criteria. As I said, one decision in the model: is this a wood door? Is the door paint grade or is it a finish grade? Limit the choices, right? And then the spec will go in and talk about the quality of the door, how it's manufactured, what the core materials are. The model could contain a hardware group, and then the specification goes through and describes what's within each of those groups. Again, if we could get the information from the spec back into the model, that has greater implications for the facilities management side of things, where it would actually be very useful to click on a door at some point in the development of the model and say, oh yeah, all that stuff is on that door, particularly with security rated stuff, so that, you know, if any adjustments were needed to be made, or if, again, for servicing requirements, that quick changes and part supplies could be verified. That would be fantastic. I've said here at the bottom, assures owner that project extras, due to document coordination, are minimized. I guess our aim is as we develop better information and information flow between specifications and the model, that in fact the goal would be that extras arising from coordination should actually in fact be eliminated. Again, this also goes back, just back up one there. This also goes back to the methods of contract delivery. Construction management, great deal of collaboration. Design build contracts, huge amount of collaboration. Stipulated price contracts, you know, the engineer, the architect is sitting there making all the decisions and basically giving a finished document over to the constructor, who then has to try to make do with the information they're given. Not necessarily the best way to fully integrate project delivery, and if that's the case. Post-construction, again, there could be materials that were used. I work with people at the Walter C. Mackenzie Hospital, facilities manager there. I'll use his name. It's John Chalupa. He's a old guy. He's been on the building since it was built, so he's been working for them for at least 40 years. And he always takes me around. Okay, you know, like before we start this next project, see that over there? That didn't work. Don't do that. You know, by the way, yeah, you guys spec'd that last time. It didn't work. We changed it out for this. Okay, well, what was it that didn't work? You know, you start asking the questions, you start doing the interview. So future substitutions during the facilities management, actually having an ability to feed back into the master specifications used by almost everybody in North America to develop their project information, that would be the ultimate goal. Just imagine that. I mean, as a spec writer, I was like, oh, this is exciting stuff. How many spec writers in the room? Okay, inside joke, okay. So, also there's the ability to record as-built information within the model, and again, for the strict reason for facilities management and maintenance of, for maintenance and asset management. I know there's a solution coming. I'll identify that shortly in about 3 or 4 more slides. But from what I'm hearing today, this is a huge thing. Tony mentioned it. The second guy, yeah, over there, my guy from San Francisco, yeah. It's not being done effectively yet. As a spec writer, I'm disturbed by this because, of course, my aim is if I write something, I actually expect it to be followed and actually implemented. Doesn't happen either, so eventually we'll rule the world. BIM is building blocks. Specs, again, it goes back to specs of free-form contract language. Describe the qualitative requirements. They don't describe size, number of things. It has a materials and products type focus, but there's also a focus on execution, not the overlap this by X or install this here doing this, this, and this. It's more the execution is how the quality of execution is, the installation requirements. Do you require trained individuals to install something, or will just a regular person dragged off the street as a casual laborer be able to perform that task? What preparation aspects to execution? Do we have to do any pre-construction testing? Right now I'm working with a concrete additive that requires trial mixes. I just finished working on a rammed earth wall at the Valley Zoo in Edmonton. And again, you're working with dirt. How do you write a specification around dirt? Well, you don't. You specify testing and performance and lots and lots of mock-ups, which is something the model really cannot do. The BIM, again, collective of element instances, quantitative. You can count stuff, you can measure stuff, you can derive areas, heights, offsets. I've heard it often at times now with a good quality BIM, you don't even need dimensions. If the contractor is fully set up with corresponding BIM software within their offices, there would be no reason at all to really do anything other than just provide, as what we've done with this magnificent metal shell for the Edmonton Arena, that model component, just give it away. They punch it into their computers. It goes through the CNC machine. They break out all of their metal components, shaped, clad it, and drop it on site. Huge potentials there. Again, element focus, one element, one product, or sometimes one element, many products. Going to come back to that again shortly here. There's a need to isolate BIM elements that require specs, materials, and products from those that do not, such as spaces. And again, this is where OmniClass is a very useful tool. There are actually OmniClass tables for spaces and for usage. And this is where information exchange really starts to get exciting. Of those that do match clauses in BIM, there are the types, the one-to-one or the one-to-many. And that once matched, they need to be checked for BIM properties, such as, in particular spec properties, we use the word interrogate the model. My unfortunate experience has been that the information being entered into the model, I share this concern with the facility managers, is that the standardized words are not often used. I've had an instance on one project where that big block of movable panels that fits into the opening in the outside of a wall and goes up when the truck comes in, often called a sectional overhead door, is called everything from overhead doors to rolling doors to correctly even overhead sectional doors or even just sectional doors. So there's an inconsistency in language that really hinders development and transfer of information even at the modeling stage between the consultant themselves. So I'm not surprised where facilities management is finding trouble finding standardized terms. But again, I have an answer for that. So express requirements in a document using contract language. Again, that's what the spec does. So what's the problem? Recognizing that a product on each side of the spec or the BIM represents the same thing. There's two approaches that I've found between two different manufacturers of specification development software. eSpecs out of the United States, which uses the ARCOM AIA type master specifications. They insert codes into the BIM that align with lines within the specification. So it looks for a code A1 over here, finds it in the spec, joins them together, enables you to click on whatever object you're looking at in the model and brings up the specification section. It's cool, but those things have to match up identically, and whoever's creating the elements or your families in the model have to be well versed as to what the metacode data is that you're trying to save and search for. The other one, and it's a new software suite, and just a little plug for David, that's what he's been developing over the last 5 years, BIM Drive. What he's done is he's got I'll call it a sidecar software package that allows the specification to sit on one side of your screen, your model information to sit on the other side of the screen, and basically associate a word in the spec with a word on the model. And every different word on the model, or every different word in the spec, so that no matter what word is actually used in the model, it'll always come out to the same word in the spec. And I'm thinking that will help on the facilities management side. With a similar tool, if you could just link to those words and just make the association, that would be fantastic. Again, the amount of information within we're always concerned about model size, and there's no way the BIM can hold 100% of the spec data. So, and again, David's pointed out here that the solution is a federated model using open standards. And there are relevant standards. Omni-class, we've mentioned quite often. I'll show you a picture of what that actually looks like later on. Open BIM data exchange, building smart data model. This is being pushed out there as the solution. And I can say so far, and I wouldn't mind betting just from the number of hands that went up when I asked if there are any specifiers in the room, that everybody else is pretty much graphically based. Fair assumption? You like to look at the pictures, right? The picture should tell the whole story. OpenBIM is geared towards that graphical data. It does not handle material data very well. So I think there's room for improvement on OpenBIM. I love the concept of OpenBIM, but at this point in time, it's very difficult to use OpenBIM to extract data from the model, and in fact to drive model information back into the BIM. So that's the OpenBIM concept there. In North America, again, Omni-class, I sit on this. Advantages, it's already commonly used. ISO has set up a standard around it. It's also used, by the way, in Japan. They love this classification system, and used it quite frequently in places like Norway, Czechoslovakia, Holland. The disadvantage is that it's a grouping mechanism. It's basically a library system. It's not one library system like the Dewey Decimal System. It's actually several library systems that all have to look at each other to complete the information as a whole. So its best use in this case is reporting of BIM entities, organization of documents, for instance the spec or operations maintenance manuals, facilities management information, and actually using what you're seeing a lot of these days, information exchange protocols. And just a quick look at what Omni-class looks like. It's very similar to master format in the sense that there are 49 or 50 tables. Omni-class has not got the population density as as master format. But here, as I say, you can see you've got constructed entities by function, constructed entities by form, which would be a very good tool for the constructor. We've got spaces by function and form, good tools for the designers. The elements, which is uniformat work results, master format, 23 products. Again, specification, the master format is not about products. It's a different classification system. 31, 32 services, 33, 34 disciplines and organizational roles. As I say, I was working on 33 and 34, 31 and 32 over the last 2 years. They are now fully populated and ready for use. Yeah, and 41, information. Information is great. That's where you put all your legal lawyers type stuff when you don't get the facilities managers modeling criteria correctly if you don't want to get sued. This is where this is where you store that information. Again, and materials are different than products. That's the components that actually make up the products. And of course, properties. So it's all about information exchange. Project information is distributed in multiple formats and changes as the documentation progresses. This is key. Development of the information. At each stage of the project, you have different information requirements. I've said quite often, and my design builders sometimes get very upset with me because I don't provide them very detailed information at the start, although it looks like I have a lot of information to base the assumptions for the PPDs and outline specifications on. But if it was appropriate to deliver full information at the beginning of the project, quite honestly, we'd be finished. So it does take time to develop the information and get it correct and to verify all of the assumptions so the constructor can coordinate with the people actually building the stuff to get it done correctly and to feed the information back to the model through those levels of development that we're seeing during the development of that information. Of course, I'm a specifier, so one of my big things is the specifier property information exchange. One of the guys that sits on my master format maintenance task team, he actually sits on the SPI task team. He's a clever guy. He's been around probably twice as long as I have, so if I'm as old as dirt, he's definitely older than dirt. But what's nice about the SPI is it actually sets up the information that the specifier actually needs to make decisions versus the information that the manufacturer would like us to know in order to sell us a product. They're two different things. We're interested in the sales stuff, but that's why, for instance, materials and properties and products are separate from work results. Work results are that whole process to an end of the construction. What I also like about the SPI is that it actually allows a reduction of product discovery. Standardization of terms. We're looking for the same, maybe not the same information, but the same information heading. Easier to find the information, therefore it actually takes less time to develop a specification. So it's a part of the overall life cycle. Again, information exchange strategy. SPI is an input tool for COBie. How do you get the information from the model? SPI is, we hope, an answer to that. So from that point of view, you see the specifier's property information exchange determines the performance standards, the equipment layout information exchange, which is something that mechanical, electrical would probably use. You can see where the information lists are then, or equipment lists are derived from specification properties. And again, warranties and spares, approval submittals and things like that all carry along with that particular component of information exchange. With a outside green box area there, which is actually COBie. And again, recognizing the flow and development of information as you go through that. There are many other information exchanges right now, and they're all being developed by I'll say, the same people with similar interests in mind. The BIM server information exchange, anybody heard of that one? This is like the whole indexing process. This is what actually allows you to create those synonyms for those different naming conventions between the working drawings, what the constructor requires, what the facilities manager requires. Building automation modeling information exchange. Again, this is something the facility manager can use to extract information from the model. Electrical system information. Some of these get very creative, sparky. Yeah, HVAC, quantity takeoff information exchange. I would almost want to see a constructability information exchange, something where the constructor can actually then identify materials and take that and create the information they need to confirm means and methods for project delivery. They're not there yet, but these are the beginning of, I think, many different information exchanges. And they actually, again, they work using open BIM standards, data definitions of processes, and in particular, this used to be called IFD, Building Smart International Foundation for Dictionaries, and they've now just changed it to Data Dictionary because nobody could remember what IFD ever stood for. This is a huge project undergoing right now. It costs a lot of money to belong to Building Smart. It's a €5,000 a year membership fee, and now they're actually starting to ask for real money to develop real information. All the volunteers are burnt out, and we've been finding that the best way to actually populate the data dictionary is actually to go to consultants and identify the consultant and say, okay, you fill in it because now you're getting paid, and we can actually hold your feet to the iron and not have to worry about our own lack of input anymore. But so last year, for instance, there was a project, and each member had to put in an additional €15,000, and there are currently 8 members of Building Smart International, so it was a lot of money. Some of the members are lucky; they have great, deep pockets of money. Norway is being one because they seem to have a lot of money these days. They have like €1 million in their account to develop information, but even they're saying they've been funding this for this development of this data dictionary for the last 10 or 15 years, and the government is now saying, you know, we're not seeing anything yet. Just at the point that we're starting to understand what's required and actually starting to deliver information. I think what you're going to see is a big call going out. I was talking to Alan a little bit earlier on about some of these issues that are becoming real problematic for final population of the information. So I wouldn't be surprised from different organizations whether or not you see a call to the construction industry in general in Canada for support of funding for development of these types of initiatives. There's another initiative through ISIS. It's an international symposium on interoperable construction. Maybe it's interoperable construction, anyway, ICIS. And they have had money, but they've been largely navel-gazing for the last 2 years and finally starting to develop actual real projects and information that comes out. What's great about the data dictionary is that the meaning is communicated. Once I know that a door is a door is a door, no matter what language I'm speaking, it becomes a lot easier to communicate to people outside of not just my own organization or my country, but to other countries. It is a consumable service. In other words, it's a web service that the software developers can actually go to. It doesn't even have to be bound into the software package itself. It can just be made as a reference. I've always been amazed these days that Internet Explorer, you can open up a German page and it says, oh, do you want to see this in English? Sure, okay, and it just translates everything for you. This is what this data dictionary is intended to do. It has other side benefits in classification of objects, can translate into any language and offer lists within the definition. So it's an electronic database of unique concepts. Concept is a term including all of the synonyms, and the synonyms are created by the user. If you don't want to call a door, you want to call it a piece of lumber that fills a hole, go right ahead, define it as you like. All you have to do is associate with it. And the ability to do that goes down to something, and Dave kind of hid that halfway down the line there. Each concept has GUIDs. So these GUIDs are unique numbers. There are so many of these numbers that you could classify the entire universe for stars populations and still have numbers left over at the end of it. So having this immense power of GUID without repeating any numbers and having associated with an object, no matter what you call that object, the number is unique. So then you can define what that object really is in your model through its ID number, not by its name. And again, data structure for the database is based on ISO standards, and those standards have been developed over the last 5 years and are now being implemented. So how does it really work? We have a CAD model, and again, it's a very good example. The BSDD UID, we put in X, Y, Z, but really a UID is an alphanumeric number, 13 characters long. Representing actually it's called a hexadecimal number, which when you convert that to binary is a number which is like trillions of zeros and ones long. So a very powerful tool. So on the drawing, they might have called it ceiling panel. It defines length, width, thickness. These are all things that are measurable and should be shown on a graphical representation of a ceiling, for instance. It has its position in space, so the Z dimension as well, not just the X, Y, and of course, an estimator can count the actual quantity or calculate the area. The data source, as in the specification, would relate to that same UID and then correctly name it acoustic panel, which is the recognized term, industry term. It would then also goes in and adds in the performance requirements such as STC ratings, flame spreads, how it's installed, whether it's suspended within or below the actual supporting structure. It also would talk about shop drawings, operations and maintenance, meetings that would get set up to review installations. So it's a very powerful tool. How it works is, and this is the door example, for instance, and this was developed in Norway, so you can see that the Norwegian flag is very prominent there. So as a door, they have the different names that it would relate to, and of course within the English term, it comes up with a number of other characteristics, what it is or what it is not. A piece of wood can be identified in several different languages as in this case a beam in English, or a truss in English then has other terms in other languages. This is how that interoperability starts to work. And this is the properties associated with the door. So the model contains the term door, but then there are all these other properties associated with which are contained within the specification. And when using OmniClass, this is how the interrelationships are actually formed between the different tables. And by the way, the solid lines here represent the actual physical links between the different databases. The dashed links would be, if you're using one set of information during your design phase, the dashed links then maintain the original association to the area requirement or the physical construction environment that the work results or the product's descriptions would actually provide to the constructor through the information exchange systems. This is an older picture before we had actually fully populated OmniClass. So right now the actual OmniClass property sets could be associated with each one of those components. And that's that for the end. Any questions?
My name is Prem Sikhan. I'm with Alberta Infrastructure. My question is, as owner of multiple facilities and as a developer, we may have 10 projects, let's say, going on at any one time. And all these projects could have a different designer, contractor, and so on and on. Does that mean that we have to buy a BIM software package for every project? And is it going to be same or different, and how do we manage it? Like, I know very little about BIM. So what do we do in that case?
That's an excellent question. That really comes down to this whole concept of open BIM, non-proprietary information sharing. And again, dealing with 10 different contractors and 10 different consultants is a big concern, because I can tell you in my office, if I have 5 different names for overhead doors, you're probably dealing with 5 different cases of that and probably called several different things at the same time. And that's where developing further the open standards for BIM information exchange is really key to a large-scale owner like Alberta Infrastructure, or I'm thinking about the airports. Tony's up in the back there. I know I had worked with Tony very early on the Edmonton International Airport, where we were setting up the PPD and trying to tie in information that we required to manage the project closeout phase at the very beginning of the project, so that, in fact, we're identifying facilities management concerns early in the project development, so that we could actually transfer that information at the end. I think it was at the very start of his master's thesis, so very key there. But yeah, open BIM standards should fix that problem for you. And no, you should not have to maintain 10 different copies of different software packages just because you're a building owner.